Thank you for joining this lesson. We're going to discuss equations of straight lines and gradients. Number 20. A straight line L1 whose equation is 3 out of 2y equals to x minus 1 meets the x-axis at P. Determine the coordinates of P for 2 marks. So the first thing we should do is to know that the point where a line meets the x-axis is usually called its x-intercept. So at the x-intercept, the value of y is usually 0. So now we'll be talking about 3 out of 2. The value of y is 0 equals to x minus 1. So we are substituting y with 0 such that we have 0 equals to x minus 1. So the value of x is now 1. So at the x-intercept, x is 1 and y is 0. So the coordinates of P, the x-intercept coordinate, will be 1, 0. Part B, a second line, L2 is perpendicular to L1 at P. Determine the equation of L2 in the double intercept form. We should know that the first line should be arranged in the form y equals to mx plus c, so that you'll be able to extract the value of gradient. So the equation which is here, I'll first multiply it with 2 out of 3 so that I remain with y equals to 2 out of 3x minus 2 out of 3. With the equation in this format now, I can conclude that the value of gradient is usually the coefficient of x. So our gradient m1 will be equivalent to 2 out of 3. Now we are talking of another line L2 which is perpendicular to L1. If gradient 1 is 2 out of 3 and there is another line which is perpendicular to this one, their gradients should have a product of -1. So we should find a gradient 2 such that when gradient 1 and 2 are multiplied, they give us -1. Therefore, the gradient of the second line perpendicular to this one should be having a gradient which is the reciprocal of this one, so 3 out of 2, and having the opposite sign. If the first gradient is a positive, then the second one is a negative. The reciprocal value with now a negative, or rather the opposite sign. So now we can talk about expressing now our gradient so that you may get equation -3 over 2 equals to change in y, so y minus 0. Remember the line is passing at P, out of change in x, x minus 1. Then we can cross multiply to have 2y equals to -3, x positive 3, because 3 multiplies x and -1, 2 multiplies y. So at this point now, remember we are expressing the equation in the double intercept form. This is to mean that we have to start with x, so the term with x, which is a 3, so 3x to this side, then we find there is already 2y to remain with 3, so we should remain with 1 on one side. So to remain with 1 now, we divide uniformly by 3, so 1 equals to 3 over 3x, which is 1x, simply x, plus 2y over 3. So this is the double intercept form for the equation. We can go to part C. A third line L3 passes through -4, 1 and is parallel to L1. Find the equation of L3 in the form ax plus by plus c equals to 0. What you should know is that the gradient of line 1 is already known, that is 2/3. Now there is another line 3 here, gradient for line 3, which is supposed to be also 2/3. If two lines are parallel to one another, they have equal gradients, therefore 2 over 3. Now that we are given a coordinate where line 3 passes, we express the gradient 2 over 3 as being equal to y minus 1, change in y, out of change in x, x minus -4, making it a +4. Now we can cross multiply. We cross multiply we're going to start with 2 multiplying x, and again 2 multiplies 4 to give us 8. Then 3 multiplies y, and 3 multiplies -1, such a way. Now we're going to stick to the format up here. So we bring all the terms to the left hand side, such that we start with 2x, then -3y. Now we are having 8 minus 8 and -3. So -3 becomes positive, and this will be 11 equals to 0. So this is the equation in the above format. The last part, the coordinates of point K at which L3 and L2 intersect. Points of intersections to be obtained, the two equations have to be solved simultaneously. Remember, if the two equations are plotted, their point of intersection will be the simultaneous solution of the two equations. Therefore, if we solve them simultaneously without plotting them, then the x and y will give us a coordinate of intersection for the two lines. The third line's equation is already here. I can write it in this format, such that I start with 2x minus 3y equals to -11. Then the first equation is here, the second equation now. Remember, L3's equation is written, so L2's equation is 3x plus 2y equivalent to 3. Let me solve by what we call elimination method. If I decide to eliminate x, then I'll multiply the first equation with the coefficient of x in the second equation, that is 3, and the second equation with 2, the coefficient of x in the first equation. We just interchange the coefficients. This will be 6x minus 9y equivalent to -33. Then 6x minus 6y minus 4y, sorry. This should be 4y. And it's a positive, sorry. Positive 4y equals to 6. So we are talking of subtraction now. So we're going to subtract the corresponding terms downwards. I can start with subtracting 6x minus 6x, that one becomes a 0. -9y minus 4y becomes -13y. This is equivalent to -39. So to remain with y, we get a positive 3. Now we can get the value of x by substituting the value of y in any of the equations. I can substitute y in the first equation such that 2x minus 3, the value of y is a 3, equals to -11. So 2x minus 9 equals to 11 negative. 2x equals to -2, and the value of x becomes -1. So the point of intersection, which is K, will be the coordinate -1, 3. So that is the coordinate K, the point of intersection for the two lines.